Everybody, this is Z Wink and welcome back to the University version 2.0 where we're going sort of a little bit differently into, I guess, the methodology I work with a lot of the time, and hopefully y'all can pick up some tips or tricks or teach me a thing or two in the process. Last video, which was the first video of this new series, I went over sort of how I go about approaching a brand new target, gathering the subdomains and doing a little bit of reconnaissance on like search engines and things like that. Today I sort of want to pick up from that and look through the subdomains of Tesla, which is a publicly traded program. They're a public program on BugCrowd. So you could stand to make some money if you could find bugs on this, and I don't expect that we're going to do that here today. It's a problem with making hacking videos, right? Like it could be really exciting if we're allowed to show live hacking and the things that we find, but right, that affects the target. If I show a live bug and you guys all, thousands of you are watching a video and see that there's a customer information leak or something, that's not good for me, that's not good for the customer. So what we're showing here is an approach, sort of a hacking methodology. I'm not like literally finding bugs, I'm not trying to anyway, live. I'm showing you how I would go about doing it. So if I do find a bug live and accidentally show it, I'm going to have to delete the video and start over, and that's frustrating for me too. So what we're going to do is hopefully do everything up to finding actual bugs and show you how I go about doing that. So all I did here so far was I started a new Burp Suite instance up. I hit Tesla.com. I haven't done anything else at all. Again, in the first video, I go over some great ways to do reconnaissance, like if you were starting on Tesla. So what I'm going to do over here is move around a couple of dialogues, so that we feel better about ourselves. I'm going to go down to like Tesla.com, just find a request. I like this one. It's nice and easy to work with. I'm going to sort of do a little in and out whack-a-mole explanation once in a while of what some things are, right? And it's a good reminder for those of us that have been doing it a long time to not forget certain things like, obvious places to test for bugs that we overlook because it's just not part of our process. Because I know those of us that do this a long time, we start getting sort of in our way of doing things and we forget to, go back to the basics sometimes and say, oh, I just completely forgot that bug type exists. So, I might mention that kind of thing here once in a while. But what I do first when I get a new list of subdomains is I find something that's just going to hit the root. Of course, this is saying I'm going to make a GET request to just the root of Tesla.com on HTTP 1.1 protocol. I usually, when I'm doing domain reconnaissance, I do 1.1 because it's sort of a little more legacy, but still likely supported everywhere. Whereas a lot of times if you hit HTTP 2 or 2.1 or something, it's going to say not supported and you'll get these weird 500 errors back. So let's do this. Let's send this guy to the intruder, okay? And so now we've got this nice big blank intruder, and they've changed the format of intruder recently, not for the better. So I'm going to move that over there. And what I'm going to do is highlight the target, which is our website address, and add that as a squiggly. And then I'm just going to paste in my list of some Tesla domains that my reconnaissance has scraped out. Some may be valid, some may be invalid. And what we're going to do here is we want to see which of these are online. And I'm going to show you something interesting here. This is not a port scanner. There's great ways to do port scanning. There's great tools out there. But just to show, for those of you that don't know or don't remember, the default HTTPS port is 443, right? So what we can do in this particular instance, we can actually do a cluster bomb attack on these domains, and we can hit port 443. Let's set it to cluster bomb. And what we're going to do is for every one of these domains, we're also going to hit a couple different ports. Just in the, I wouldn't normally do this unless I had a reason to, but I wanted to show it as part of the video, just as some interesting ways you can use the intruders. So for position 1, we've got our list of domains. Position 2, let's add 443 and let's add 8443. We may not even get a single response back on 8443, but it's always kind of interesting just to show. And what we'll do here is set the resource pool to something astronomically large, so this goes really fast, like 999 requests. And for the settings, we'll tell it that we don't care about retrying on network failure in the event it's down, and since we're not going to retry, this probably doesn't do anything. And let's just go ahead and start getting some results back. Now, this is the way I do my first sweep of what is out there. So we've got subdomains of a target. So we know it's in scope. You know, if this was a star.tesla.com or anything Tesla owns kind of engagement, right? And I usually sort on 200 ascending. Why? Well, this tells me things that are supposed to come back or do come back okay. It's saying, oh, you have access to this. I'm good with that. And it gives you a 200 okay, right? That's what 200 means. The status code in the response header is 200. If we look at that, you see it says HTTP 200 okay. I'm happy to have you here. Please download my data. That's what 200 means. As we scroll down the list, if we get a 301 back, it's saying, oh, that's great, you found me, I'm here, but I want you to go somewhere else. It's a redirect, right? So normally there's a redirect URL. In this case, there's a location header redirecting you to a specific page on that site. So the redirects are often really interesting because it gives you a sense of what's there and what sort of architecture behind the scenes might be driving things, and also what security is kind of running there, right? So a lot of times things that are sort of guarded by Okta, a lot of times you'll hit these websites and it'll redirect you to the Okta dialog, right? And that's, you see that sort of behavior a lot with the 301 redirects. 302 is sort of the same thing, just temporary versus more permanent. 403s, okay, so 403s, of course, we're used to seeing 403s, which generally mean you don't have access, forbidden, you cannot get into my website, I don't want you in here. But sometimes, don't just stop if you get a 403 back. Like a lot of times if you get a 403 and then you just hit a different path other than the root, you might get a 404. So a lot of times just like the root domain itself a 403, but if we send this to the repeater and we try to get like robots, for instance, .txt back, it might not 403. See, that was a 403 at the root, but it was a 404 not found if you just hit a file. What does that mean? I don't know. It could mean there's a security misconfiguration that leads to stuff you're not supposed to be able to get to, or it was an unintended thing, or it could just mean I'm not going to show you the root because I don't want to, and it's something set up wrong, and it's meant to be accessible, and yada yada yada. Anyway, don't just take everything at face value. You gotta play with it, right? So that was 403, but maybe pages and files and other things aren't. 403, of course, is an error that can be specific to very precise API calls. It's not like a domain-wide thing all the time. So keep that in mind. And then, of course, as we go through the list, we also have 404 status codes come back. That means not found. That means there's not a default page set up at the root, but it means the domain is there because we got a code back, and it means now you get to play seek and destroy and figure out what lives out there, which to me is part of the fun. I love 404s. I love websites that you have no idea about. You don't know what runs out there. Becomes a little bit of a treasure hunt, right? And then we have our 500s. Yeah, just 500s are like, it blew up, something done blowed up. Now, don't forget when you see 500s or any other response code to check the headers. This is telling me it's running Microsoft IIS, which is cool. Tells me they use Microsoft, tells me they use IIS. Probably running on, I don't know, Windows Server 2008 or 2016 or some version of that. John, I don't remember which started using IIS 10. But then now things come into play like IIS short name scanner. Is it susceptible to IIS short name scanning? So can I start fuzzing directories here and then running short name scanner to find hidden files or things I'm not supposed to be able to get to? So that comes into play having seen Microsoft IIS. And you start getting sort of an idea as you click through them of what sort of a corporation they are, what kind of technology do they use. We have NGINX here, of course, that's real common. So as I'm going through this, we have a WAF, Akame, however you say that. So we've got some WAFing, that's not unexpected. And as you can see, we're already finished with our scan down here. So at this point, out of the, 1,700 or so domains, there were very few on a percentage basis which were actually internet facing on any of the ports. Let's see if we had any on 8. We did actually get 3 responses back on 8443, which is kind of cool. Don't know that it's meaningful in any way, but it's interesting to note that there's other ports running there. And if you ever want to know more about a specific domain, you could use something like census.io. Typing that out here, that is census.io. If you go to census.io, it lets you type in that domain, and then you can see all the ports that are actually open. A lot of this recon has been done for us. You just need to find the right tools that are out there to tell you. But this is the way I like to do things. I like to get my eyeballs on it first and see what's out there. Now, The next big thing you need to do, right, of all these things that are on the screen, is make a big decision. As Bob Ross, the painter, would say, now we need to make a big decision. We need to pick one of these that we want to go look at that looks interesting. Now, when you get on a new target, there's some schools of thought here. Everybody works a little bit differently. Let's go back to our pretty Tesla website here. Look at that. That is a sick looking car. It probably goes really fast. I'm not going to try to go through the front door of this thing. You go to bugcrowd.com, you look at Tesla, you see it's got, I don't know how many, over 1,000 bugs logged and paid out for it, right? It's been beaten, it's been hit. I normally am not going to create a customer account right here, right? And just start going right at the front door on a program as big as Tesla. That's like, to me, that's probably a low return on investment of my time. Like, I would have to work really hard probably to find something that was missed on the main Tesla.com website login dialog. It's been beaten to death. It's had 500 external pen tests. Everyone on the internet's tried to hack it. You know, like, that's not what you do. And if you're not finding bugs, think about that, right? Because you don't want to go necessarily where everybody else has been first. Now, if your goal is just to, to make yourself feel really good because you found a bug that everybody else missed, this might be the place to look. And everybody hacks for different reasons. For me, that's not the one. So I'm probably going to try to find something weird that maybe has been overlooked. That is a payable bug. And if everything for Tesla is in scope, and I don't know if it is because I didn't pull up the brief because I'm not actually hacking Tesla right now, every one of these things are potentially fair game. So you think about Tesla and the amount of PII it's got, the amount of automotive infotainment, the ability to control vehicles, potentially solar arrays, and all these products and things they've got. There's a lot of juicy stuff out there that's probably not living at www.tesla.com necessarily. Now, granted, that's probably the main portal for customers to log in and interact with, a large quantity of intended APIs. But that doesn't mean you can't get to some really interesting things directly via some little interesting back doors here. So we're about 12 minutes or so into this video. I'm going to try to keep these shorter because what happens is everybody has the attention span of a gnat in this generation, and if I do a 45-minute video, nobody's going to watch it. So I may actually just stop here with this one and then pick up exactly in this file where I left off going after a target. But I think it's really important to note this methodology because it lets you see what's responsive, what's out there, what the status codes are. You get the domain names, and you start getting a sense of the technology. Now, if you wanted to take it a step further, you could come over here to let's see if we can figure this guy out. Oh, why is it on the wrong side of the screen? Okay, all right, so what we could do is settings, here we go. We can look for specific keywords. So let's say we wanted to know, for instance, what's running IIS. We can come back over here now and actually sort descending. Didn't work for some reason. Let me search for computers. Oh, I hate the way they've changed this interface. You get used to a thing and then it changes on you. Let's search for Microsoft. Is it? Oh, it's excluding the headers. I'm sorry. You see that? There's a box that says exclude headers. All right, so I searched for IIS. I got 4 websites back that noted they were running IIS. You can search for Microsoft, and we can see anything that has the word Microsoft in the response. So maybe you were going just after Windows or just after IIS to kind of get a sense of what they were doing. It looks like this just has maybe some code in there. But let's see what we got here. My app Tesla. Man, that's got a lot of headers. X ad block key. My app Tesla. Now, I don't know of all of these which I would actually go after first. This is driving me nuts. Can I kill that? Cool. And let's just see what I might look at first. Fleet view is interesting, right? Because the concept of viewing a fleet isn't normally a customer concept. The fleet meaning more than one vehicle, some group of vehicles, maybe all the vehicles, I don't know. Maybe that's for customer support to view every single Tesla vehicle on a dashboard. Sounds pretty high risk. And as you can see, their content security policy is allowing auth.tesla. So, there's some authentication that's going to have to happen, or it expects to happen. Let's just do a thing. I won't keep this video too much longer, but let's say we wanted to look at Fleet View and see if we could find anything at all on it. So we start with a search engine maybe and just see if anything has been indexed. Doesn't look like anything meaningful has been indexed. So let's hit the website. Interesting. All right, so you can see it tried to load some GUI stuff before it bounced me to the OAuth page. Now, that's interesting to note because a lot of times in today's modern architectures, what people are doing is they're like, oh, you went to the website, I'm going to load all the JavaScript and the GUI, and then I'm going to bounce you to the login dialog. That's good. It's very convenient for the hacker because what that allows us to do is see all the code that just loaded that we would have access to utilize after authentication. So the redirect doesn't work as well as it could. Like, it should redirect prior to loading any code from the page, but it doesn't. So what we're going to do real quick is I like to just sort of look at where the specific code might be coming from for this website, and it looks like there's some stuff from CDN Design. Let's see, my big face is in the way again. Nope. Might just all be coming from the Fleet View website itself, which is cool. So if we go over to the Fleet View America website, we do have a JavaScript file which got loaded. Not a lot in it by any means. It's not actually it may be bigger than it looks. It's half a meg. Okay. So we can do something like send that over to Gap, which is a tool that parses out URLs to just give us a quick, a look at the code. And we can see already that there's an API vehicles page. We've got a reference to some command and a fleet API and stuff like that. So we start getting a little bit of data about this thing leaked out. Now, we don't know where this lives, so it scraped that out. What we can do is say burp search, and you search the response bodies, right? When you see an indicator, you figure, okay, that's the file that it was in, and now we go right to the file where it was at. That allows us to backtrack in the code and sort of see maybe why this is being called. And people are always asking me, hey, do you need to learn JavaScript? I couldn't write this if I had to, but I can read it. A lot of it's sort of obfuscated with the little E's and the D's and the N's and the S's and great. I really don't care about that so much, but I do care about this. So one thing you have to ask yourself when you find an API is, does the API live on this domain or does it live on another domain? And if it lives on another domain, it's 99% reference. It's like there's a 99% chance it's probably referenced in this file. So one option is, search for HTTPS. And you can find just, all the HTTPS links in here, and you'll find a lot of times whether or not there is like an API path or something that it's, appending to. It's likely that in this particular case, the API in fact lives on this website itself, this domain. So if we send this to the repeater, let's just take this guy, send to the repeater, and just hit that path, and we're going to say just give me 100 per page, sure. Tesla Fleet View. So that's not the API, because that's just trying to return back the HTTP content again. So that's not where it's at. But then you look here in the content security header, and we say, well, that's interesting. There's a whole bunch of cool domains listed up here. Maybe it's this one, or something. So maybe we come over here and we see what this is. I lost my browser window. I accidentally closed my browser window, guys. How on earth did that happen? And that's a website too. Yeah, so now we got to figure out what gives, right? So we've got some API paths, and the API path itself isn't returning the data. So this is where you have to backtrack in the JavaScript. We see a reference to Fleet API. We see command. It could be that it lives at the fleet API stem and that was just appended. I'm not digging through the JavaScript heavily here right now, but that could be the missing piece right there. And there we go. So that is the API for this fleet view, and as you can see, it says bearer realm doorkeeper invalid token. The access token is invalid, which makes sense because I didn't even give it an access token. Now, like I tell a lot of people, I love hunting auth bypasses. I love hunting, IDORs. Now, this is probably something where if you got any access token, you'd be able to have a whole lot of fun on it. Now, while we're here, and again, I'm not trying to find vulnerabilities live because it screws up the whole deal, but as you can see, we went from, very quickly, here's a whole list of subdomains to here's some responsive subdomains to here's an interesting looking subdomain to now we've found the APIs that live at this subdomain, which I don't think anybody would have just arbitrarily guessed, because they leak the JavaScript files prior to authentication, and now all we have to do is get an auth token. Well, that's what the whole internet comes down to now, isn't it? A username or password or a string that represents one, or a developer that somehow screwed up code and allows you in. I'll show you a couple things here quickly, just as a note. So it is expecting an authorization bearer header, probably of the format EY, yada, 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 which is normally a JSON web token. They could be taking something else here. It would require a little bit of research to find out. Sometimes authorization can be totally bypassed by doing dumb things like adding a slash to the end of a path. I have seen this before, and it's real. It somehow messes with the routing for security, depending on how their configurations are set up. It's terrible when it happens, but it happens. So, if you're just looking for a generic 401 bypass, it almost never works, just being honest. But if it does, it's big, easy money, and it lets you in. So a percent, try that. Try a %2f. These are all just little URL encode quirks, right? %3f. Fascinating. So that actually doesn't even register on the back end as the same route. So it's not actually checking for security on that, but that makes sense a little bit. %3f should be a URL encoded question mark unless I've had a total breakdown. URL encode all characters, yeah. So that's just actually being written back on the back end as an actual question mark. It's like, hey, that doesn't exist. So you can try multiple slashes. You can try semicolons. You can try the pound sign. You can try a URL encoded pound sign, in different places and different formats. Hacking a lot of times is just tinkering and trying to screw things up, okay? I don't know right now if it's letting me through the API or if that path's actually not found. Maybe it's expecting something else. There's more research to be done there. Like if I give that a 3, do I get the same thing not found? If I give that a slash, do I get access denied? No, I don't. So that means it's probably checking that. Back to unauthorized again. Sometimes you can, if there's a V1, a V2, or a V3 or whatever, this is just a number, you can actually go backwards to a 1 or a 0 or something, and weird things happen. Sometimes you can do weird things like .. slash test slash, so it's going to go back to vehicles. It's just dumb things like that registered as the same URL. Anyway, you get the idea. It's all about tinkering around. And one thing to think about too, let's say you have a Tesla.com auth token, right? Well, that was obviously generated from a valid signed source. Try your Tesla.com auth token on all the websites and APIs you can find at 401 or 403, right? A lot of times they don't check the scopes or the roles or the issuer or something like that, and your customer token may work on like an employee website or something like that. So that's another idea. But trying to keep these a little shorter. It looks like we're at 25 minutes. So next time I'll pick up on something related to this Tesla stuff. I think we'll just keep going through it. It's kind of fun because as I go, I sort of just think of random things to mention. Just don't forget, everybody, there's methods you can do. A lot of places to hack. We're literally just looking at the path right here, but you've also got method hacking. You can sometimes circumvent security with a post instead of a get, assuming that the security for some reason is only checking get, and it also allows get, post, patch, etc. So try different methods and see if those bypass. Not a bad idea. And then of course there's weird headers you can inject. You can try host stuff. If there's cookies are injection points. Obviously if there's payloads are injection points. We'll get into all that, but I don't want to bore everybody to tears. I know I'm getting bored, so hopefully this helps, and I'll be back soon with another video. Thanks so much.